Hi everyone, and welcome back. This is Unit 4.6, Permutations. It's actually not in our book per se, it's just kind of a combination of different things from here and there. So when you try to look it up, it won't be in there. But my notes should be enough to help you out. All right, so let's go ahead and do the bell ringer. We'll put your name up at the top in your class hour, of course, like we always do. And today's date. And then go ahead and do the bell ringer by yourself, and then we're going to grade it all together. So go ahead and do that, and then when you're ready, come back to me, and I will work it out with you. All right, let's take a look at the bell ringer. It's scheduling. It says Colt is planning his Saturday. He wants to mow the grass, go swimming, and do his homework. How many different ways are there to arrange what he wants to do? Fill in the blanks of the organized list below to find all the possible arrangements of the activities. So the first one he can do is go mow first, then go swimming, and then do his homework. He can mow first, do his homework, and then we would go swimming. He could go swimming first, mow, and then do his homework. He could swim first, do his homework, and then do the mowing. He could do his homework first, then he could mow, and then go swim, which is probably what I would do, because after homework, then you can go mow, and then once you're hot, then you can go jump in the pool and cool off a little bit. Or you could do it the opposite way, which would be do homework first, go swimming, and then mow. Okay, so you could get all wet, and then while you're mowing, you can dry out, I guess, too. All right, so how many choices does Colt have for his first activity? He had 3, right? Once the first activity is selected, how many does he have? How many choices does he have for the second activity? That would be 2. And then once the first and second activities are selected, how many choices does Colt have for the third activity? That means there would be 1. Okay, there's only 1 left. All right, and let's go ahead and turn the page, I believe. Yeah. All right, so let's take a look at permutations. All right, again, it's just a different kind of math. I don't know really how to explain it. It's just different. Okay, so let's see. Oh, there it is. All right, so what are we going to learn for today? What you'll learn is to find the number of permutations of a set of objects. Find the number of permutations of a set of objects, and then we're also going to find probabilities. Find probabilities. All right, so what exactly is a permutation? A permutation is an arrangement or listing of objects in which order is important, okay? So like on the last example that we just did there in the bell ringer, we wouldn't mow twice, although we would like to go swimming twice. We definitely don't probably want to do homework twice. All right, so there's a certain order in which we need to do things, and we can't repeat anything. All right, and that's what we're going to look at for today. All right, so the first one we're going to look at here is something with school. It says, Julia is scheduling her first 3 classes. Her choices are math, science, and language arts. Use the fundamental counting principle to find the number of different ways Julia can schedule her first 3 classes. All right, so how many classes does she have to pick from the first time? Well, she has math, science, and language arts, right? So that would be 3. Okay, now we're going to select one of those. So how many are left for her to pick again? That would be 2. So we're going to do times 2. and then we're going to pick the last one, and there's only one left to pick from. All right, then from here we multiply those together. So we have 3 times 2 times 1, which would make 6. All right, let's try example 2. It says an ice cream shop has 31 flavors. Carlos wants to buy a 3-scoop cone with 3 different flavors. How many cones could he buy if the order of the flavors is important? All right, so they're talking about Baskin-Robbins 31 flavors. They can't call it that because that's copyright issues. So basically, how many different 3-scoop cones can we get if we all get different colors or different flavors each time? All right, so let's take a look. So the first time he walks into the store, he's in front of the whole huge buffet full of ice cream. How many buckets can he pick from? Well, there's 31. Okay, now he can't use that one again. So how many does he have to pick from now? That would be 30. And then he can't use either of those two again. So how many does he have to pick from now? That would be 29. All right, so go ahead and grab a calculator. If you don't have one, pause it and go grab one real quick. So we're going to do 31 times 30 times 29. That's going to come out to 26,970. 26,970. All right, so obviously there's a million different ways. Not literally a million, but it seems like a million. All right, so you can have all kinds. All right, let's try the 2 guided questions. So go ahead and pause it right here and try those down there by yourself. And come back to me just as soon as you're ready. And let's take a look. So part A says, in how many ways can the starting 6 players of a volleyball team stand in a row for a picture? So if I had 6 people to pick from for the first position, so we'll say farthest to our left, so as for the photographer, it would be on the left side. Okay, I have 6 different people to pick from. Okay, once I pick that person, then I only have 5 more to pick. And then 4, and then 3, and then 2, and then 1. All right, so how many different ways can we do this? So we have 6 times 5, which is 30. 30 times 4, which would be 120. 120 times 3 would be 360. And then 360 times 2 would be 720. Obviously, the 1 doesn't count there at the end. So there's 720 different ways that those people could stand in a picture, which is crazy to think about when you only have 6 people, but it would happen. All right, letter B. In a race with 7 runners, in how many ways can the runners end up in first, second, and third place? Okay, so this time I only need 3 of them. All right, so in first place, so if we're all running and we're all coming in, that means 7 people could end up winning first place, right? Okay, now that person's walking it off and getting a drink of water. Okay, then the second person comes in. Well, one person's already finished, so how many possibly could end up in second place? There's only 6 people left. Okay, they're cooling down. The next person comes in, and the only number left to pick from is 5. All right, and then that's it. So we're going to take 7 times 6 times 5, so that's 42 times 5, and that should come out to 210. 210. All right. All right, so instead of multiplying all this through, there is actually a little bit shorter way to do this. Okay, and we're going to use the permutation symbol. All right, so here's what this means. So when you see P31, 3, okay, what this means is there's 31 permutations taken 3 at a time. All right, so what that means is the very first number you see, which is 31, is the number that you start with. The 3 tells you how many factors you need. And remember, you subtract 1 from each one. So in the previous answer, you would do 31, 30, and 29. Okay? Now, the good part about this is your calculator does actually solve these for you. All right, so go ahead and pull out your calculator and let's practice typing these in. All right, so we already worked out this one. We already know that 31 times 30 times 29 from the previous answer was 26,970. 26,970. So we already know that that's what the answer is. Well, here's the quick way to find it. Okay, so what you're going to do is you're going to hit in 31. Hit in 31. Then you're going to hit the PRB button. PRB button. So let's do 31, and then we'll type in PRB. Okay, you're going to select the one that says NPR. Okay, that's the permutations button. So you click that, so you'll click enter, which is equals. Okay, then we're going to type in the other number, which is 3. And then you're going to hit equals again. All right, and when you do that, it tells you that it's 26,970. All right, so make sure you got that wrote down. That should be a B there. PRB. There we go. Okay, so instead of you trying to figure out all the multiplication, because honestly, if this was 31 and they wanted to take in like 25 at a time, you don't want to have to sit there and multiply 25 numbers out. Like, that's crazy, right? Okay, so the calculators are pre-programmed in to do that for you. All right? So let's try that on the next one here. Oops. My stupid doc keeps popping up. There we go. Okay, so we're going to do the permutation of 8 taken 3 at a time. All right, so let's just write out what that means. So it really means 8 times 7 times 6. Okay, now we don't want to do 8 times 7 times 6. So we're going to type in 8. We're going to do NPR and then 3. All right, so let's type that in. So let's do 8 NPR 3. So we're going to do 8 NPR 3, and it tells us it's 336. And that should be the right answer. Yep, 336. All right, again, that NPR is on the PRB button. PRB button. Okay, I want you to try just letter C by yourself, okay? Just letter C. Don't go ahead to letter D because there's something special I'm going to show you with that one, okay? So just try letter C. All right, let's take a look. So letter C is the permutation of 12 taken 2 at a time. So we're going to do 12 NPR 2, and that makes 132. All right. Now, the next one is a special one, okay? This is actually called factorial, all right, and an exclamation mark, okay? What it means is when you're going to use all of the factors up, like a while ago we had 31, all right, if we want to actually use all 31 up, we don't want to type in all those numbers, right? Well, sometimes it even gets repetitive to type it in 31 NPR 31. You can just type in 31 and then the factorial key. All right, so what this means is 4 factorial. All right, or for non-math people, it means 4 because it's excitement, right? Yes, everyone's like, why do you have exclamation marks in math? Well, they're not. Okay, it's factorial. So it's not 4, it's just 4 factorial to us. All right, so to do factorial, what you're going to do is you're going to hit in 4. And then when you click the PRB button, you should see NPR, NCR, and then you should see the factorial, which is the exclamation mark. Okay? You click that, and then it's going to tell you 24. Now, will you get the same answer as using NPR? Yes, you'll get the same answer. It's just you do need to know that there is a such thing called factorial, all right, because it really does help you out in the long run. Okay, so 4 factorial means 24. Okay? So that means 4 times 3 times 2 times 1. All right, so that's a special one. Okay, let's try letter E by ourselves. It's not a factorial question, so you'll just do a permutation of 10 taken 5 at a time. All right, so let's take a look. So if I take 10, or if we have 10 and we're going to take 5 at a time, that's going to come out to 30,240. All right, 30,240. And that's it, okay? So just remember the little factorial thing there, and you should be okay. All right, let's look at example 4 here. It says Ashley's MP3 player has a setting that allows the songs to play in a random order. She has a playlist that contains 10 songs. What is the probability that the MP3 player will randomly play the first 3 songs in order? All right, so for this one, we're going to do the permutation of. Okay, well, how many do we have to pick from altogether? There's 10. And how many am I allowed to pick? I'm allowed to pick the first 3. Okay, so we're going to do the permutation of 10. And then we're going to do 3 picks. Okay, so we'll do 10, NPR, and 3. And we should get 720. All right, now the difference is they want to know what the probability of this is. Okay, so that means there's 720 ways to do it. And you guys know by now that when you find the outcomes, it's the same as the probability. So there's only a 1 out of 720 chance that she's actually going to get it to play the first 3 songs in order. All right? And I always laugh because iTunes is crazy. All right, you guys know I like to play music a lot, and it seems like I'll put on a whole playlist, and it tends to play like the same artist over and over and over again, even though like they're together, but it should like randomly kind of pick from like the beginning and then the middle and the end, and then back to the middle and then back to the beginning and all that stuff. Like I could have 15 hours worth of music on there, and it seems like it plays like the one artist over and over and over and over. Not necessarily the same song, but just the same artist. So even though I've got several on there. Which is crazy, but that's just how it is. Okay, let's try example 5. It says a swimming event features 8 swimmers. If each swimmer has an equally likely chance to finish in the top 2, what is the probability that Yumi will be in first place and Paquita in second place? All right, so let's take a look. So we need to set up a permutation. So our permutation is going to consist of 8 swimmers, and we're going to take it 2 at a time. All right. So even though it wants to know specific people, the odds or the probability are all the same. Okay. So for this one, we're going to do the permutation of 8 taken 2 at a time. So let's go ahead and do that. So we're going to do 8 taken 2 at a time, and we should get 56. All right. So then what's the probability of it? I'm sorry, 56, not 54. Or 52, sorry, whatever I had there. 56, there we go. All right, so then what we need to do is find the probability, and again, we know that the probability is the same as the outcome, just as a fraction, so it's 1 in 56. All right, so there's only a 1 in 56 chance that it's going to happen. All right, let's try the got it question by ourselves, and that's it for today. All right, let's take a look. It says 2 different letters are randomly selected from the letters in the word math. What's the probability that the first letter selected is M and the second letter is H? Okay, so let's do a permutation here. So our permutation would consist of, there's 4 letters, and I need to pick 2. All right, so for this one, we're going to do the permutation of 4. Picking 2. So that's just going to be 4 times 3, which would be 12. All right, so that makes 12, which means the probability then is 1/12. And that's it. Okay. All right, that's it for this lesson. I know it's kind of a weird one, and when you look at it, it's like I have no idea what that means, but once you get the hang of it, you find out it's actually pretty easy. Okay, just remember that you're going to use the PRB button, and then if you do need a factorial, remember factorial is where you're using all of the choices, so it would be like 31, 31, 4, 4, 5, 5, 6, 6, 7, 7, and so on. Okay, when you use all of the choices, you can use the factorial key instead of the NPR button. All right, so thanks for watching. Have a good one, and I'll see you next time, and don't forget to give me a like and subscribe if you haven't already. Thanks, bye.